Welcome to the GeoSWM Quick Start tutorial. If you're working with stormwater, wastewater, or urban flooding, you're in the right place. Today, we're diving into a quick start tutorial for GeoSWM software. We're assuming you're already comfortable with Esri's ArcGIS Pro and the SWMM model, and that you've got GeoSWM up and running on your computer. So, let's get started. In this quick start tutorial, you'll get familiar with the GeoSWM interface and understand how it integrates with ArcGIS Pro. You'll learn how to build a basic stormwater network model using real GIS data layers and assign the necessary hydraulic and hydrologic parameters. We'll guide you through setting up simulation options, running the model, and visualizing outputs like runoff hydrographs and profile plots. By the end, you'll know how to simulate rainfall runoff in a catchment and export your model for use in SWMM or other compatible tools. Before we begin, let's get on the same page about what a drainage catchment or watershed is. Basically, it's an area that directs excess runoff to a common water body downstream. In urban settings, this process is really affected by impervious surfaces like roads, buildings, and parking lots, which stop water from soaking into the ground. This leads to faster and larger volumes of runoff compared to rural areas. To manage this increased flow, cities use engineered systems known as urban stormwater networks. These networks capture and transport runoff through roadside drains, storm sewers, manholes, and various control structures. The goal is to tackle issues like waterlogging, urban flooding, and water pollution. Urban stormwater networks are designed to work with the natural landscape of the watershed. Different subcatchments throughout the city collect stormwater and channel it to larger drainage outlets. Proper planning, design, installation, and maintenance of this stormwater infrastructure are key to sustainable stormwater management in any catchment. In this quick start tutorial, we're going to create a simple stormwater model for an urban catchment area using GeoSWM. If you've got GeoSWM installed on your computer, go ahead and open it now so you can follow along with us. It's also a good idea to have the second chapter of the GeoSWM user manual and the GIS datasets for this tutorial open, which should be included in your software package. To begin with, create an ArcGIS project with a new map file. Let's name it Quick Start Tutorial. Let's wait for a few moments. So, here we are with a new ArcGIS Pro project file open with new map on the screen, and you should see the GeoSWM tab along with other tabs of ArcGIS Pro. We'll use the different tools on this tab to build our SWM model. Keep in mind, GeoSWM offers several ways to build a drainage model, but in this tutorial, we'll focus on just one of those methods. Now, let's get back to our task. To build our model, we'll start by using the sample datasets from the Quick Start tutorial. First, let's add these datasets to the ArcGIS map from Map tab, Add Data option. Click on Browse. We have GIS shapefiles for rain gauges, drainage subcatchments, storm sewers, referred to as conduits in GeoSWM, sewer junctions or manholes, and drainage outfalls. If you don't have these datasets handy, don't worry. You can always digitize them on the map or use GeoSWM's pre-processing tools to create the necessary data layers with the right attributes. Alright, the datasets are now added. On the map, you should see 1 rain gauge, 3 subcatchments, 5 conduits, 5 junctions, and 1 outfall. Next, we'll create a GeoSWM model, which is essentially a file geodatabase. To do this, click on the Project button on the GeoSWM tab Project section and select New. You'll need to enter a project name, file path, and coordinate system. If you're familiar with ArcGIS Pro or any other GIS software, you know about map projection systems. Since GeoSWM works within ArcGIS Pro, your GeoSWM project will use a projected coordinate system for its GIS data layers. If your map already has a coordinate system, you can choose the same one or specify a suitable one. It's a good idea to use a common coordinate system for all your data layers, GeoSWM project file, and map to avoid any confusion or data errors. For this tutorial, we'll use the coordinate system of the sample GIS data layers that are already in the map layer panel. So go ahead and specify the file name, file path, and coordinate system. Just make sure not to use any special characters in the file name or path. It may take a few seconds to create the new GeoSWM project file, so please keep patience. Great! We can see that our GeoSWM project file has been created and is now displayed on the map layer panel. Along with this, there's a new panel showing a tree structure that outlines the different components of a standard SWM model. We will call it Model Object Panel. Once you've confirmed that the project has been successfully created, GeoSWM will prompt you to decide whether you want to assign model input data to this project file. This step is optional, so you can choose to do it later if you prefer. But if you select Yes, a window will pop up with options for assigning model input data. Let's go ahead and select Yes. A window will pop up with two options: Import GIS data or Import EPSWM 5.1 input file. Let's choose Import GIS data since we'll be working with attributes from the sample GIS data layers. Here we go. The model data creation window opens, and we'll start by assigning inputs for the different data layers. First up, let's handle the subcatchment data layer. In the Source Data field, specify the sample GIS shapefile for the subcatchments. The panel might suggest some of the attribute fields for the required parameters. We'll use the attributes provided in the sample datasets. Keep in mind, it's not necessary to fill in every data field right now. You can leave some out if you need to. Just follow along and assign the relevant fields. Once you've assigned all the fields for the subcatchments, move on to the next layer, like the conduits. Repeat the same steps for conduits, junctions, outfalls, and rain gauges. When you've completed assigning data for all layers, click the OK button to finalize the model data creation process. And there we go. Now you should see a replication of the sample GIS data layers within the GeoSWM project file. This is your model workspace. Since we've imported the data, we don't need the original sample datasets anymore. Feel free to turn off those layers or remove them from the layer panel. You're all set with your basic GeoSWM model setup. Next, we'll assign some important tabular or non-GIS input data, like a rainfall time series and essential parameters for hydraulic computations. If you're interested in simulating water quality, you'd also need to assign water quality parameter data, but we'll skip that part in this tutorial. To start with the rainfall time series, go to the time series option on the Model Object panel and click on Add button to open the editor. We've got a simple text file named TS1 that contains some time series values, which is included with the sample datasets. You can use this time series data by keeping the text file open and either copying the values directly into the time series editor or manually typing them in as you look at the file. The time series editor offers various options for data entry or import, so you have flexibility depending on your needs. So, let's enter the rainfall time series values by using import options. Now, let's move on to setting up the model simulation options. Here, we'll configure parameters for the rainfall infiltration model and set the time steps for hydraulic computation and result reporting. We'll leave the other parameters at their default values for this tutorial. For the infiltration model, the default option is green amped, and we'll stick with that. Next, open the subcatchment data table and expand the infiltration block. Enter the parameter values according to the user manual. All right. We have done it. Click OK to save the entries. Now, let's set up the dates and time steps for the simulation. These settings are pretty straightforward, and any SWM user should be able to handle them. Just be careful with the simulation duration, reporting time steps, and the routing or computational time steps. For detailed info, check out the SWM reference manuals. For now, we'll follow the instructions from the user manual and input the following. Analysis duration, 12 hours. Routing time step, 60 seconds. Reporting time step, 15 minutes. Runoff reporting time steps, 5 minutes for wet weather and 1 hour for dry weather periods. Click OK to save these options. Your model is now set up and ready for simulation. Before we finish, let's give your project a title and a short description. You can do this in the simple text editor located at the top of the Model Object panel. Just enter the title and description for your GeoSWM project, and you're all set. Now, go to the Project menu and click Save button to save all your inputs. Now that our model is set up, we're ready for simulation. Just to recap, we've created a simple stormwater network model to simulate rainfall runoff. We'll observe how the model responds to the given rainfall time series. To start the simulation, go to the GeoSWM tab, Run section, and click the Run Project button. If there are no errors in your model inputs, GeoSWM will activate the simulation engine and you'll see a progress bar. Keep in mind, the time needed for simulation can vary based on the size of the network objects, time steps, and duration. Once the simulation is complete, you'll get a notification from the model. Here it is. GeoSWM provides various ways to organize and present your model simulation results. In this tutorial, we'll focus on 3 key areas: the status summary, subcatchment runoff, and flow through the storm sewers. First, let's check out the status report. You can access it by clicking the Status Report button on the GeoSWM tab, Results section, Reports category. This report is a well-organized text file that offers detailed input and output information about your modeled network. It's a great resource for quickly viewing critical details like continuity errors, runoff summaries, and result tables for subcatchments, conduits, and junctions. Now, let's use the time series plot option from the Plots category of Results section to view runoff or flow hydrographs for a drainage catchment area and its storm sewers. We'll start by checking out the subcatchment runoff hydrograph. We should also explore the Profile plot option, which allows you to see the horizontal section of a storm sewer segment and observe how the water level changes over time. Let's take a look at the segment between junction J3 and outfall O1. Here, you can see a representative view of the conduit layout and water surface elevation along that section. The chart even features an animator tool that lets you watch how the water surface elevation changes throughout the reporting period. Let's see it in action. Here we go. Creating a standard SWM input file for your GeoSWM project is a breeze. Here's how you do it. Go to GeoSWM tab, Project section, and select Export SWM Input File. Then, just specify a file path and name for it. And there you have it, the input file is created. This file can be used directly in EPA SWM 5.1 or any other SWM application that accepts SWM input files. That wraps up our tutorial. Today, we've covered how to quickly set up a simple stormwater model using GeoSWM and run a runoff simulation. For more learning videos on GeoSWM, check out utilien.com/geoswm/videos. Thanks for watching.